Guys, in this video I'm going to talk about another interesting problem. This also is a very popular question among interviewers and it is on lead code. The question is to find the kth smallest element in a binary search tree. The description says given the root of a binary search tree and an integer k, return the kth smallest value of all the values of the nodes in the tree. Looking at the example, this tree here 3, 1, 2, 4 and k is 1, which means that we have to identify the first smallest element, and first smallest element in the tree is 1. So let's just get on with how I would solve this problem. So this is typical in order traversal kind of problem where you are doing root, left and right, and what you have to do is that you have to count the kth smallest left item, and that is the value that you should be returning back for this particular problem to solve. So that's what we would do. I will have to use some class level variables. So let me define few of them, and result is the one that I will use to return back. So first up, I would just check if root is null. That means the tree is empty. So I have to return res. I'm defining keeping k in a global variable so that the helper function that I will create to do the in order traversal in recursive manner, I don't have to supply back the k value every time. You will see it in a minute. So this is my helper function. What I'm going to do is void helper root. So in order traversal, as you know, this is what we do in an order traversal. We would do root dot left helper root dot right, and this is the part where we have to count for the left nodes, and we have to count a variable I plus plus, and when I becomes the target, that's when we have found the kth smallest element. Alrighty, so this is, we have found our result. To just not do further recursion when we have found our result, we could use this variable here j. So only when it is we have not found kth smallest, that's the part of when we want to recurse. Otherwise we are done, we are good to go. There isn't any further recursion we have to do. So that is we have result here, and we can just return res from here. Okie dokes, I think this looks really good. Let me just run it now. Compile error. It says identify expected. What's going on here? Ah, yeah, I need to define the type for root. Now I think we should be good. Whew. are good. So let's try and submit it. So yeah, works really good. In terms of time complexity, so we are visiting every root of the tree. So the time complexity is O(n). And for the space complexity, although we are not creating any other data structure to hold the tree values, etc., but since we are using recursion, so recursion adds up to the memory requirement, and it would be again of the order of O(n). So I hope you guys like the video. Let me know if you have any questions for this one, and I will get back to you on your comments. Thank you.